Hi, David. Thanks for joining today.
Hi, Glenn.
Hey, so today's going to be about Git internals. Hopefully, that will be something that is very exciting. Um, I have a couple of prerequisites and some couple of slides to go over with you. So for the Git internal slides, um, first, just a couple of prerequisites. So if you're just starting to watch this, you're participating, or if you're someone new, you should be comfortable with the command line. If you're not, then it's probably going to be a little overwhelming today. You should already have Git installed and a basic understanding of Git. If you're watching this trying to say, look, I want to understand how Git works, it's probably going to be too detailed. And you should be genuinely interested in learning more about Git because we're going to get really, really deep into it. And today's purpose is we're going to really try to go over creating a new repo, and there'll be a lot of hands-on watching and seeing what's happening underneath. We'll change some branches. We'll actually review what Git objects look like. We'll dive deep into Git objects. We'll do a Git. We'll at least briefly talk about the concepts of a Git hash. We'll use the git cat-file command because that's a very helpful part for us to actually see what's happening with objects. We'll start comparing branches, seeing what's happening without making too complex of a branches. Cherry pick a little bit, do an interactive rebase a little bit just to see what's happening there, and hopefully have time to talk about working practices. So that's mostly what we hope to get covered in the next hour or so. How does that feel?
Sounds fun.
Okay, excellent. So what I'd like you to do, if you don't mind, is can you share a terminal screen with me so we can kind of start? And I'll have you creating the database, the Git internals branches and repo for me.
Yep, I just shared it. Can you see this?
I can. That's perfect. Okay, go ahead and make an database screen. Go ahead and make a database directory of any kind. Make dir example, whatever you want to call it. We're going to work out of this directory. Okay, internals. So good, cd to internals, and now what we want to do is we want to actually, inside of internals, we're going to make a brand new Git repo. And to create Git from scratch, that's done with the git init command.
We're not just that?
Just that.
Okay.
Okay, so it says that we've initialized an empty Git repo. Ah, perfect. And you've already said, well, I don't see anything. What do I see in the directory? An ls-a shows that there's a .git directory. Do an ls-al to show that that actually is a directory and not just, you can see right there that there's a directory on the left. Perfect. So that is the directory. It's actually something inside of it. And if you'll ls that directory and look at the internals, you'll see that there are a lot of data structures there. So there's something called branches, config, description, head in all uppercase letters, hooks, info, objects, and refs. We're going to dig pretty deep today on heads, objects, and refs.
Okay.
Make sense? So in that repo, if I were to type a git log command,
yeah.
Go ahead. What do you think you will see?
Oh, well.
You've done. Great. So we will see this really wonderful error messaging that gets famous for, that tells us exactly what's going on. Or not. Maybe not so wonderful. But after a few minutes, I think you'll understand what this message is saying. So what does a git log normally show you? Do you remember?
Yeah, it'll show you the last couple commits that you've made, the commit messages,
right?
Like some other information about it.
Yeah, and since we don't have any commits yet, it makes sense that it can't show you a log. The message is weird, but the idea that we get an error is not so weird because we've not made a commit yet. We've really just created a new repo with no commits in it. So bad default revision head. Wow. The only thing I look in there that says that's kind of familiar is if you look at your ls above and you look at head below, they're the same thing. So let's take a look at it. So type cat and look and .git. Well, you're going to do .git to the subdirectory head. Perfect. So you actually have something called head that is readable. It's a text object, and it looks like it's a reference to refs, heads, master. Yep. So that's pretty cool. We can actually see what's going on and catch up pretty quickly with that. So very, very cool. So you have something called head. Why don't we go ahead and I can see you're already jumping on. You're like, oh, okay, well, there's refs, heads, master. I saw refs as part of my data structure. So let me just go look in there. Ah, and you noticed When you were
There
trying
is no master.
yeah, you were doing type ahead, tab completion, I could tell, and you're like, wait, there's no master. So this is the error it's complaining about. It's saying, hey, look, .get, the head, is what .get always uses to point to things. Head
Yep.
is pointing to master, but master doesn't exist. So that bad default revision head message is really saying, I'm looking for your first commit. Head points to the master branch, but there is no master branch. There's nothing there. I can't find it. And that's why we can't create our, we can't go on. And while you're doing that, I'm going to go ahead and I'd like you to go ahead and create a first commit. And while you're
Okay.
creating that first commit, I'm going to start preparing a whiteboard so we can kind of see what's happening. I like your license.
Okay.
Okay. So I like your license and I like your commit. Your first commit basically says anyone can use our repo. That's great. So if you were to look at what I'm showing, you can actually see that I have a head that was pointing to nothing. That was
Yep.
what I was saying before. Head pointing to we don't know. Let's do the same set of commands we'll be doing a lot of times. Let's actually look at what your head is now pointing to. So go ahead and just cat.get/head. Okay, so it still points to ref heads master.
Yep.
So let me go ahead and in my whiteboard, if you'll hold on for me for a second, I'm going to change this to say master. Okay, so I have heads pointing to master. We had that before, but we didn't really understand it. But now let's go ahead and do the same cat you did before to say what does master point to. Yeah, go ahead. Perfect. So instead of reading the whole hashes, I'll probably take the first 4 or 5 letters. But you now have, Git is now pointing to something. So when you actually have master, these refs are for references. So I have a reference that head's pointing to. It's the master branch, and it's the head of the master branch, and this is what that master branch is. And so because we can cat, that means that it's not a binary file, it's just a plain text file. And it's pretty cool that we're digging in and seeing the details of that text file. So we're going to throw the git command away soon. Except for one thing, we'll be doing everything without git command. All right, so in my graph real quick, let me go ahead and put 629B. So 629B, I'm going to erase what was here just to kind of show what we're doing. And I'm going to change this to 629B. Was that correct?
Yep. 629BA. Yep.
Okay, that's even better. Okay, and then I'm going to draw my pointer right down here so that we have a pointer to 629BA. Okay, well great, and we can actually see what the structures look like, but that's not as helpful yet because we're still pretty detailed without seeing what's happening. Why don't you do a git log again?
Okay.
And now you see that the git log did the same thing in the fact that 629BA is the commit message, or the commit hash. Okay.
Yep.
So you have the first commit, and your head is pointing to the master branch, and the master branch is pointing to a particular commit. And that commit somewhere happens to have the information that we're looking for, that you're seeing in git log.
Mm-hmm.
So I don't see it yet on how we've done it, so let's take a look again at your .git subdirectory. So ls.get, and let's see what objects we see there. Okay. So we see head. That's what we've been using so far. We see refs. We've looked in refs because head seems to point to things. It has references to different refs. And there's something else that I mentioned. We have branches, what we've looked at before too. You have config that some people have looked at. But we also have objects. Do an ls of objects, and let's see what it is. Perfect. Okay, I don't see the immediate correlation, but do you?
Well, there's a 6.2, and this commit starts with a 6.2.
Perfect. That's exactly what I was going for. So it doesn't have the entire commit message or the commit in here, but it does have the first two. And that 6.2, because it's blue on your screen, tells me it's a directory as well.
Yep.
So go ahead and ls the .get objects 6.2 and see if there's anything else there. Okay. 6.9v. Okay. I can see the entire commit message. This is pretty simple.
Yep.
Why did we take the first two?
I guess when you're generating the hashes, if once you don't want this directory to be too enormous, I guess.
Yeah, you have limits on how many files can be in a directory, and if we're going to hit those limits, why don't we split it up by taking the first two characters, and we can have many directories that could hit that limit, have less content in it, so we have less of a chance of hitting that limit. And just having two is enough, because these limits are pretty far out there for where we are today. So okay, so we actually so far have been able to look at everything. We just catted that directory of a head. We actually looked at its references, and for the references we found the objects. We've gone into the object subdirectory, and now we know where the object is. We don't need the git command. We can do it all manually if we wished. Almost. That would be a painful life, I know. I forgot to, one thing I need you to do is to look at that command, but don't cat it. I'll warn you that it'll mess up your terminal. So why don't you, have you ever used vi minus some kind of vi command, or how do you normally look at a file that might be binary?
Oh, I don't.
Okay.
I use file to print out some info about it.
Let's do file. And then you'll want to finish the file name there. Okay. So you'll see that it is a particular executable, not script. It's not even executable. It's a binary file. And if you were to look at those contents, are you familiar with VI at all?
I'm not great, but I can do it. I'm an Emacs user.
Okay, if you can get in and get out, that's all we need. So type view instead of view is not VI. It's like a read-only version of VI. Yeah, just do that. So you can tell at the top there's a bunch of garbage data. So that's kind of showing us not just the file command, but showing us that is really garbage data. So, okay, I cannot read this directly. So escape :q, perfect. That means that I have not changed that file at all. Good. I believe that that's actually a binary file. Yep. So dreams of never using the git command are being a little crushed.
Yeah.
No worries. I have something that I can use that's a git internal command that is somewhat helpful. So type git. And then we're going to use something called cat-file. There's another argument. Yeah, go ahead and type that in. There's another argument we're going to need, so we'll backspace when you're done, when you're ready for that. So one of the first arguments, if you did this without the argument, it would say the syntax. It needs an argument to know what you want to do next. There are two arguments that can be helpful for us. The first one is the type, and if you just do a space -t there, and it says, all right, I have an object in the object database. What type is that? This will actually tell you. Go ahead and press enter.
Not a valid object name.
Oh, it took me a second to see it. Oh, sorry. Thank you for doing that. You did exactly what I said, even though I was wrong. Everything we've done before has been exactly following the data structures underneath. But cat-file is actually a git command, so it doesn't. It's not going to operate on the file exactly. We're going to say git. I want you to cat a file of this object. So don't give me the file path, even though it's the same thing. Just give me the hash, which is the 629B, and take off that. Yep, right there. Try that. That's actually you can tell what it's doing. Underneath, it's actually saying, oh, okay, that's in my .git directory. It's an objects. The first two is 62. Here's the rest of it. I found the file. You want to cat it. What do you want to do with it? You want me to see its type? Okay, I can check its type. Oh, look, it's a commit object.
Okay.
Okay, there are different kinds of objects in here. We've only been looking at commits. And today it's really just about looking at the commit so we can kind of see what's happening. But you also have something called a tree object, which we will see today, but we won't go into details on. And you also have other types of objects too, at least one other. Okay?
All right.
That's great, but it still doesn't help me see my log command. So what I want to do now is not use the -t, but I want to use a p for pretty. So t was for type, p is for pretty. Okay, press enter. So this is the actual thing that we'll create the hash out of. And look, it looks very similar to your git log. It has something called a tree. Hey, look, if I were to go just real fun for fun, type git cat dash file space minus t. It might be a little bit more typing because don't use the use that object. Yeah. So we want to say the object that's here in the tree object. Let's just type it. Perfect. And what type is it? Okay, it confirms it's a tree object. So if I were to go into trees later from the commit object, I would explore that path.
Okay.
But for now, we just know that, hey, if you'll press up arrow twice and give me the minus p for the pretty one just to see it's last on the screen again, yeah. So I have something, I have the actual tree, I have the author, I have the committer, and I have the commit message. Oh, and what's to the right of the author and the committer? The exact timestamp.
Got it.
So this information is what's used to calculate the hash that's going to create the 629B. So if you were to say, let's say you follow this exactly again tomorrow at exactly the same time tomorrow, and you were to do the exact same steps that we did, would your hash be the same or different?
Probably the same. I don't know if the time is a part of the hash.
Oh, look to the right there, right past author.
Okay, well, and this is part of the, okay.
Yeah. So, but you're right, exactly in thinking if the time weren't part of the hash, you're exactly right, it would be the same. But because time is, you can see how the chance of having a hash collision here is incredibly unlikely.
Okay.
And even then, as we will see for the next step when we get into more details, you know, your first commit's one thing, but what happens when you have another commit and another commit? And we will see that in a few minutes. What about an author and a committer? We have two things. We have one that's an author and one that is a committer. So they're the same person. And did you know that if you had someone else's work, that you were able to pull that work and say, look, I want to take that commit that someone else has done, and I want to pull it into my branch. They're the author, but I'm the one who's committing it into my branch. You can see how it would have two different names, the original author and then my name for committing.
Yep, I've never done that before, but...
Haven't done a cherry pick? Not yet?
I've sort of followed instructions, but not known what I was doing for a cherry pick. Yeah.
Well, say no, because I want to show you toward the end.
There you go. No is close to the truth, yes.
Okay, good. So we'll hope to do cherry picks soon as we look at these structures and do some changes around. All right, so I think if you do a git log right now and you look above, we have very, very similar data structures. You don't need the git log command. I'm sorry. Yeah, you don't need the git log command. You've done the same work by using everything above, by looking at the internals, except for the cat file, which helped me look at the contents. But other than that, you've not used the git log command, and you can see what's happening. Great?
Yep.
Let's make another commit. I'll let you do that however you'd like. I like your commit messages. And I like how you're doing it in one terminal. That's nice. Okay, so what you've done is you've actually changed a file, the README file. Now you've added that file to the repository, and now you've made a new commit message that actually has the message of I've added the README. So let's start from the beginning on the git log command, but don't use git log. We're going to do it from scratch. Pretend that we broke our git command. And let's look at what's going on. And let's do it together. So first things first, let's look at the head. What does head look like? Good. Okay, so refs heads master. Let me quickly switch over to my screen while you're doing that and say, okay, head points to master. So that hasn't changed. That's great. Okay, let me switch back to your screen. What do I see? Go ahead and, yep, you see that heads is a pointer to these directories. Oh, perfect. And so now it is a pointer to the same hash. And hold on for me. You're great. You're doing good. All right, so is it pointing to the same hash or a different hash?
Different hash.
Ah, so that's perfect. So my video or I'm sorry, my whiteboard is now wrong. I no longer have this pointer to that hash. I don't know what happened to it, so I'm just going to leave it hanging. I'm going to leave that out there somewhere, and I'm going to draw a new one right here. Yeah.
70E08.
70E?
Yeah,
70ED8?
that's a 08.
Oh, 08. Did I get it right?
Yeah.
Perfect. Okay, and you're saying that head now has, I'm sorry, master has a pointer there.
Yep.
Correct? Okay. So great. We'll draw that in the same line. We don't know what this is. This was weird. We're just going to ignore it for now. All right. So go ahead and do the next step, which you had already started typing. You're going to do a cat file on the P for pretty. Don't forget your P object to print out the contents. Your P argument, I mean, to print the contents. Great.
No autocomplete.
No, because it's not a file. It's only a hash as far as it's concerned. Okay. So this makes sense. This is what you just last committed. Oh, but wait. If I were to look at the details, tree, I've seen tree before. Parent.
Ah, yep.
That's new. But I have author committer in the message. So this hash is going to be, I have this hash, but what is that parent object? How do you think we can find out?
Probably do a cat, by doing a cat file? Or?
Yeah. Let's do a cat file on, and let's do the type first. Just to be clear, let's first do a type of the parent to make sure, yep, good. Good. And press enter. So it's another commit. So the first commit is pointing to a different commit. All right, so before you go on, let me just quickly make sure I have this in my picture. So 7E08 has a parent. What was its parent?
Its parent is 629BA.
Ah. So look at this. It seems to point backwards. So we always point to the last one, 70E08, but it's now pointing to its parent, which was the previous one. All right. So go ahead and then say, all right, I see the parent. Let's follow the parent and dump it as well. So do a minus P for the parent, like you did the T above. And what you have on your screen looks a lot like a get log to me.
Yeah. This is the parent again, same one before.
Yeah. So if you were to type the get log command,
okay,
you receive the results, it would be almost exactly the first one and then the previous one. It looks great, almost the same. Can you up arrow twice just to go back to your 2 commands ago, that one, and let's look at it one more time. So that's the first commit that we have. I don't see parent.
Right.
Why?
Because it has no parent. That was the first commit.
The first one. So really, the get log command, if we wanted to by code, we could write our own script that would do the same get log. If someone took our getaway but let us have a cat file, we could start with whatever we were, wherever we were. We would go to head. We would actually look at whatever it points to. We would grab its hash wherever it is in the tree. We would then we'd dump the contents of that hash. We would find its parent and dump its contents. We would find its parent and dump its contents. And we would go until finally there was no parent, and then we would stop.
Yep.
Okay, so we understand exactly what getlog is doing from its internals. That's pretty cool.
Yep.
All right, great. Then let's move on. Let's do something new, fun, and exciting. Let's now decide to make a new branch. So go ahead and type. And to keep it in 2 steps for those who are watching, let's do a get branch and a new branch name, and whatever branch name you want to give it.
I never do it this way, so I just type in the new branch name.
That's right. That's right. You probably do it all at once. Oh, and you want to make that branch name, that whole thing there is actually the branch name. It's not new branch, but like new underscore branch, my branch, Sally's branch.
Okay. Wait. So sorry. Is this good?
The space between the new and the branch is what has me crazy there. Make sense?
Yeah, it's an underscore, but.
That's why it didn't make sense. I didn't see the underscore. My apologies. From where it was on the screen, I could only see that it was a space. Okay, then that's perfect. All right, let's pretend that we are getlog, and let's look at what's going on now. So first thing I want to do is I always look at the head. So let's cat Oh, pretend we're get log, but we're actually going to do it manually. So cat.get/head. What do you think it's going to point to? Trick question, by the way.
It's going to point to 70E08 because we haven't switched branches. Or,
So,
oh,
yep, that's a trick question. It's not only, it's actually going to point to the different branch that we're on. So the head's actually not just what hash that you're on, but what branch, which points to the hash that you're on. And what branch that we pointing to? We created a new branch, but we didn't actually change to it. Yeah, I intentionally did that. So do an ls of your .get/refs heads. Yep, and do heads. Yep, and you can see that there's actually two references there: master and new branch. But what we're currently pointing to is
master still.
Master still, because we didn't do it. So now just get checkout new branch, which is the step that actually changes it. And I think what you're used to doing is actually creating and checking out in the same step with the checkout -b command.
Yep.
Yeah, that's fine. But breaking it in 2 steps, we can see what's going on.
Yep.
And now if you cat that, so go ahead and do a cat.get/head. You should see, hey, we're pointing to the new branch. Okay, so give me a second. I need to make a picture that's up to date. That was so 2 minutes ago. All right, so I'm having a hard time typing here. So this is not the most elegant in the world, but that's okay. It's functional. Okay, so new branch. And this part of the picture is wrong. Sound effects free. Here we go. New branch. But we have no idea what everything else is looking like. So everything else looks like. So go ahead and help me see what would you do in this case.
Get refs new branch. Oop. Heads new branch.
Perfect. And it has 70E08. 70. Oh, okay, fair enough. So I'm going to draw an arrow from here to here. Oops, let me switch so everyone can see. I just had, this was what it looked like. I had just drawn an arrow right here, but I hadn't switched screens yet. Okay, so we now see that head points to new branch. Master points to 70E08, but so does new branch. But if I were to make any changes, where would they go to? What branch would it be put on?
New branch.
Yeah, exactly. In fact, that's what I kind of want to do right now. Let's go ahead and go back to, go ahead, what were you going to say?
Oh, nothing. I just said okay.
Okay, so let's go ahead and make a new commit. And to prove where we are, go ahead and just do a get branch so that everyone can see what branch we're on. Okay, it was the new branch just like we saw on the internal structures, and then make a new commit. You're going to have to make a new file or add something to another file. Oh, Python as well. Awesome. Echo instead of cat. Very good. Okay, and so you'll add code.py. Great. All right, let's do the same step we've done 100 times now. Let's look at what the pointer points to. I know it's pedantic, but let's do. So cat.get/head, what does head point to? It points to new branch. Wait for me, let me switch pictures. Head is pointing to new branch. Okay, that's good. All right, coming back, and you are now going to look at what that branch points to. Okay, head's new branch, good. And it's, oh, that's different, C973A. Switching to my picture, C973A. I don't have it anywhere. It's a new commit. So C973A, I think I said correct.
That's right.
Okay. So, and maybe drawing it right there wasn't the best place to draw it because I'm going to have to draw arrows around things. So new branch no longer points to 70E. All right, let's take that away. Okay, that's going away. And I'm now going to draw around this. Whoops. Sorry about that.
No problem.
That's not what I meant. I meant to take an arrow and draw new branches pointer. Okay, I'll do it this way. Around to point to C973A. Okay, now go ahead and just pretend you're get log and work your way backwards. Let's see what we see.
What is it? Oh, cat file.
Cat dash file minus P for pretty. And we've seen all of these are Git commit hashes, so that's fine. Now we have a parent, so you just pointed to parent of 70E0, and if you were to quickly do the same thing on it, we should see that it's the previous commit. Okay, and then there's no parent. Oh yeah, there's one more parent, there's one more, so we'll do it again.
Okay.
Okay, and then we're done, and there's no parent, so we're done. So is that reflected in our picture so far? So
You gotta draw the parent from.
yeah, I just need to draw I saw you do this, but I didn't draw it in my picture, so let me draw it now. I actually have that pointer from 973A to 70E08 all the way down, and that makes sense. So if I were to switch to new branch, which is what I'm on now, I would have 3 commits. And they would start with C973A, back to 70E08, back to 629BA, and then would be done. If I were to switch to the master branch, and let's just do that real quick, but before you do, switch to the master branch, then I would actually just have 2 pointers, 70E08 pointing to 629BA. So,
Want me to do that?
yeah, let me switch so everyone can see your screen. Go ahead and do that. So just switch branches again. So just check out master, and then just do a git log. It'll be faster. Just to do a real git log, and you'll see that there are only 2 commits. And we can look at the hashes 70 to 62. So graphically, we can start seeing what the internals are looking like. Does that make sense?
Yeah.
All right. The only thing I didn't do is I didn't, like internally, when you switch branches, all I did was just change that, like how hard is it internally, what O notation or how difficult is it for Git to change branches. I simply changed the head pointer from that branch to that branch. Super simple, super efficient. Okay?
Yep.
So I can have branches diverge and draw this picture in any way I want, but clearly I can just have these different branches pointing to these different branch pointers. So it's really head as a pointer to whatever branch pointer, and those branch pointers are all pointing to different parts of the tree. So if I wanted to, I could be able to take things from one part of a branch and put it onto another part of a branch, and I'll do all kinds of things like that. But before I do, I'd like you to switch from head back to new branch. So git checkout new branch. Great. And now git log, you should see 3 things. Great. Now I am going to change my pointer to reflect what you just did so that we all can see what's happening. I'm just switching this one pointer back and forth. And now I would like to do something new. I would like to do something called a git amend.
Okay.
Okay, so you're going to git commit -- amend.
Is it?
Yeah, I think 1M.
Oh, 1M.
Yeah, I think so. I always make the mistake, so I never know until I've done it once. Great. Now, unlike before where you had you were been doing it by the command line, you have an editor that comes up, but that's fine. You can change something, but let's pretend that you don't have to. Control X to save here.
Okay.
We have amended that commit, but we changed nothing theoretically. Well, it appears to me that we've changed nothing. Do you think that we've changed anything?
Probably the timestamp. And
Yeah.
so.
Yes, the timestamp. So if I were to go look at that git log real quick, so I'll notice that that top hash
Yeah.
is different. So I have rewritten this commit. It is now 70.
07EE.
Okay, let me switch to my picture and type in 07EE. And so I have really changed that commit. And I've only changed it by changing the timestamp. That changed its hash, but everything else was the same. Its parent still pointed to the previous thing. I didn't change its parent or anything else. All right, so I can actually change history by simply, just by doing an amend, I am actually changing that commit. And if I were to actually have given my copy of this repo to someone else, and they've already updated all of their pointers to talk to everything that we're pointing to, and if I were to do an amend, I could make things very confusing for that person who's now pointing to a different hash than what we're pointing to.
Yes.
Okay, and I'm sure people have seen that before if they ever share branches and change history on that branch after it's shared. Okay, what I'd like to do is move back to master.
Okay.
So let's get checkout master. Great. Get log, prove that there are only 2 commits there. And I should have had you, if you can scroll up, great. If not, we'll just have you switch back. But I'd like you to save in your buffer the hash of that top commit. I believe it was 07EE.
Okay. I'll just make a note of it in another window.
Okay.
That...
That's fine. Yeah. I think it was 07EE something, and that's probably good enough.
Yeah. Yeah.
Okay, so since you switched back, while you're doing that, I'm going to update my picture. So we just switched to master, I believe, correct?
Yeah, we're in master now.
Okay, so now we have head pointing to master, which is pointing to commit 70E08. Master doesn't work back. There's no arrow from master back to 07EE. Master doesn't even know about that. Okay. So 07EE is not on the master branch. It is in our object repository. It's in that database of objects, but master doesn't have a path to it yet. But what I'd like you to do is I would like you to say, you know what? I want you to take a commit from a different branch. I want you to put it into my current branch. And I want you to update the pointers so that it's the commit in question.
Okay.
That's called a cherry pick.
Got it.
Yeah, so just to prove to everyone where we are, let's just do a get log again. I think you just did. So get log, we have 2 commits. The last one is 70E088. I'll switch screens real quick to show that 70E08 is what it's pointing to. So now let's type git space carry dash pick and then that commit message.
The 07EE?
The one you pasted from the other branch.
Yeah.
Okay. So basically master doesn't know about that commit. It doesn't follow the master part, but what we're going to do is say master, great. All right, let's now do a get log. Okay, I see 3 commits there. It has even added code, added readme, and first commit. So let's go and look at my picture and see what needs to be done. So master doesn't point directly to 70E08 anymore. It did, but it doesn't now. Do you agree?
Yeah, I agree with that.
So it points. Go ahead.
It's actually not pointing to 07EE either, though. It's pointing to E0BB.
Interesting. Very good. All right, then let me not draw this interim picture. Let's go draw a picture of what's going on. And let's look at everything from the beginning. So just a quick, looking now at your screen, do a quick cat.get/head so everyone can see. And that's refs heads master. So quickly I'll switch back to my picture. So head points to master. Good. Okay, switching back to your screen. Let's look at what? Good. So what does it point to? It points to E0BB4. Back to my picture. You're right. It doesn't point to that one. It points to something called E0BB4. So let's go ahead and...
It's because we amended.
We had to change. So E0BB4, correct?
Yeah.
So I now have E0BB4. Master is now pointing to that particular branch. And then I'll switch back to yours. What is its parent? So if you'll do a quick git cat dash file minus p in that hash. Yeah, and its parent is 70E8. Agreed?
Yeah.
So it almost looks like we have a 707EE and a E0BB4. They're very, very similar. They look identical, but they're actually different hashes.
Yeah.
And if we were to go look at the objects real quick, let's do a git cat file on two objects. So in your buffer, we're going to use the one that's 07EE and another one that's E0BB4.
07, oh boy.
Okay, that's okay. So the last two, if you'll do a get log on that branch, perfect. Yep. And then just cat file minus p. But don't forget your minus p. And then do it again on the last branch. Yeah. And don't forget the minus p. Perfect. Hey, added code, added code. So when we look at what's going on, sometimes we aren't actually changing commits, because changing commits could actually change anything upstream. What we're doing is making a new commit that's identical to the old one, except it's not identical, it has a different time. Yeah, and there you go. Your committer and your committer time there has changed, because you're doing it not at the exact same time. You're doing it at the same time. Does that make sense?
Yeah, and the author time is still the same, though, because I didn't actually make any changes.
Exactly. You committed that commit at a different time, but you didn't actually write the code at a different time. And that could be so confusing. If you look at my graph, I now have crossing streams. As much as I tried to keep things in one line to keep it simple, we could redraw this, but we'd run out of time. But we really have 2 pointers. And really, we have a box on one side and a box on the other side. And really, they both point to this object. So I'm going to hand wave just a little bit, only to save time, that we have something that looks about like this. And for an exercise, we could do this on our own, reconstruct this and see what's going on. So you can see that we both have 2 different pointers from 2 different branches pointing all the way back in time, back to the original. Make sense?
Yes. I don't see where new branch has an arrow leaving from it.
I left it hanging. Thank you for catching that. Let's draw this now so it makes more sense. And hopefully I got the arrows to the right ones. A new branch's pointer is actually to the right commit. This one, so if you do a get log on new branch real fast, is it 070E, then 70E0, and then 629?
Yep.
Perfect. Okay. So we're starting to see how these branches look, and it's very counterintuitive the first time ever anyone starts looking at this. They think that anything new that we're doing is going at the head, like in the very top, and they points forward. And I think it's very confusing for people to start seeing how we're pointing backwards. But it's so efficient. Each one of these things, it's one thing to switch branches, and it's one thing for us to just add a new commit and then just have its parent point to the previous. I don't have to do any more work down the tree. It's already done. So efficient. It is very, very elegant that way. I love it. But you almost have to know its internals to know what it's doing sometimes. All right? So I think that that's a lot, but I'd like to throw one more thing on if I may.
Okay.
All right? Don't forget, well, 2 more things really. I'd like to do something, and then I'd like to talk about the consequences of doing something. So both of these things, both of these branches look like they have almost identical histories. Get log between both of them. Like your git checkout master, get log, git checkout new branch, get log. If you're not observant to the commits, you would actually say that they look really similar.
Right.
right? Because they are almost identical.
Yep.
I'd like you to pick one of them. I don't care which. Yeah, you do. Let's pick new branch, just to be more systematic. I think that's a good one. So git checkout new branch. The nice thing about watching this as a video is anyone can pause if we go too fast. So if I start speaking too fast, that's okay. We can just pause. I would like you to completely change the entire history of all of this, going backwards in time. I am, and I will show you how. I'm going to say, you know what? I don't like this history. I think adding code pedantically makes a lot more sense than adding a README. Now, in real life, I don't. A README makes more sense, but I'm trying to make an artificial example. All right?
Sure.
So what I'm saying is, first commit, add code, add README. I don't know what the README looks like until after code. And generally, I don't do it that way. I do it just like you just did it, but I'm going to force that just for now to make you have to swap 2 commits.
Okay.
All right? So the 07EE comes after the 70E0, which comes after 629B. And I'm going to switch it so that 70E088 is the top one. It points to 07EE, and it points to 629BA. And that's called an interactive rebase. Okay? You will need a text editor that comes up, but what we had before was fine. So get rebase space dash interactive, and we're going to rebase the last 2 commits. And I'm going to say head tilde 2, and there's no space there.
Right. Say that again.
Head no space tilde 2. Yeah. Okay, press enter. So it might be hard for some people to see what's going on, but if they can see, there are 2 different commits at the very top. The very, very top one is the added README, and it has the small abbreviation of the commit to it. And the next one down is added code. So I could have actually had, if I had 20 commits here, I could have rebased 20. What did the head tilde 2 mean? It just says from head, which we now know how to follow it back, go back. So from head, which is that commit that it points to, now take 2 of those from it backwards, and now take those and put them in this window so I can look at what's going on. And I have lots of options. I can squish them into 1 commit. I can reword the messages. I could, yeah, exactly, as you're putting your mouse down, I can actually edit the actual commit, so I can change the code as I'm writing it. I can do all kinds of fancy things. But all I'm going to do today is just pick. I'm going to use the commit. If I were, don't do this yet, but if I were to press to save this, it would rewrite that history exactly the same structure and the same path it has now, just different hashes, because the time would be different.
Okay.
But we don't want to do that. We're going to switch lines. So it works backwards. I'm going to take that top line and move it 1 below the one it is now.
What editor am I in? I don't know how to copy and paste. Whatever.
I think you're in Nano. Yeah. Do you have 3 commits there or 2? Oh, perfect. I see what you did. That's great. Nano is a really simple editor. It's mostly just copy and paste and then control buttons.
Okay, so that's all I'm doing is I'm switching the order?
That's all you're doing is switching the order. So that means it's going to say, okay, take the top one, but it's going to basically reapply those commits, but in a different order. So Control X to save that. Control X, do I want to save?
Okay.
Save, yes please. File name, enter. I'm going to not change it. Let it do its thing. Successfully rebased. So you see your git log from before. Added from backwards, it's added code, added README, first commit. Or from the top down. Now do it again. Yeah, git log. And now it's add README, added code, first commit. So you've changed history.
Crazy.
And more importantly in changing that history, you actually, did you just have 2 picks or 3 in your terminal? I can't remember now.
I had 2.
Okay, good. So the very first one's probably the same then. All right, let's take a look at this picture. And let me just go ahead and remove all of what I see here because I have a feeling that this can get really confusing if we try to show everything. Let me erase all of my arrows, leaving a little red and whites, just like a real whiteboard. I'm leaving little smudges. And I am, what branch were we on? New branch?
I'm on new branch, yeah.
All right. So far, the picture looks about like this. Now let's work our way and see what's going on. Oh, I should have left those hashes so we could have compared. Okay. So go ahead and do a cat.get/head. Yeah, press enter. And so you can see it points to new branch. So cat space dot get slash, yep, refs, heads, new branch, and it's pointing to 9D. So I didn't think to leave the other hash in, but we can always rewind that to go look at it before and draw our own pictures. 9D, what was it?
9D4D.
Okay. So that points to 9D4D. I don't remember that hash.
It's a new one.
It's a new one. And it points to, go ahead and follow its parent like before. Oh, I'm drawing pictures, but no one can see what I just did.
I can see it.
Yeah, but only one of these is visible at a time, and I just switched to the visibility on the recording for this one. So I just erased this other whiteboard stuff. I put this up, and I pointed from 9D down. All right, so go ahead and do your next one.
Git cat file 9. Okay, its parent is 1F00.
Okay, let me switch over and then type in 1F00. Again, I don't recognize that commit. Not that I can remember all of them, but they do seem new for me. And it still has a parent, so I'm going to draw another empty box, and let's go look at it.
Yep, its parent is 629B.
629B. Okay.
Which was there before.
So we recognize that one. So really, and I will draw this in blue, we had the exact same old picture, but these commits, even though identical information except for some committing time, are new. These commits kind of got rewritten because they're new. And the old commit, does that make sense?
Yeah.
And your old commits, all of that old stuff, they're not being pointed to in our pictures because we only have 2 branches, but they're still there. They're still in our database. We don't go back and delete them until the end. So go ahead and do what's called garbage collection. Git space GC, that's garbage collect. Let's throw away that other stuff we don't need that we're not pointing to anymore. So data compression, writing compression, counting the objects, not a lot. It's not the biggest repo. And at the end of the day, we have deleted and cleaned things up, and so we now have just the stuff that we're pointing to, and we have a fairly good understanding of what's going on underneath, I think.
Okay. Did it get rid of anything?
Why don't we do an ls of objects? The .get/objects. Wow. Where'd they all go? It got packed. So it was kind of an unfair for me to actually show things because it doesn't just do it doesn't just do what I was doing, but it also does some efficiency of cleaning up. So it wasn't as helpful. I should have actually been able to keep the old hashes and go look at them. But yeah, it cleaned things up. It also packed things so it was more efficient for storage and things like that. So at the end of the day, let me go ahead and switch screens that I'm sharing to my original slides. So I will stop sharing this, and I will switch over to my slides that we started with. And let's see how we did. So we created a new repo. I think that's pretty obvious. I think we did pretty good with that one. It's just that .get directory, that .get directory that we created. Changed branches. I think that was pretty easy. We could see what was happening underneath when we changed branches. We see the objects. Some really cool things going on with objects. And we actually dove deep with how to look at them. And we kind of understood what hashes were doing by the actual content that was being hashed that created those hash objects, those hash IDs. used cat file to go look at a lot of those things, and we compared those two branches. We cherry-picked from one of the Git branches. We did an interactive rebase, and the only thing we have left to talk about is the working practices. Don't forget that a Git repo from GitHub, for example, or that a Git repo that you have pushed or pulled code from, all of your pointers are pushed and pulled from someone else. So I might be pulling code from GitHub that someone else has given me, and if they change their pointers that I assume are already correct, they're pointing at something different than I am, and that can be so confusing. In fact, it could cause a total Git hell situation.
Yes.
And if you have never seen Git hell, it's pretty messy and pretty bad. Because at the end of the day, the pointers are different. But if the person at GitHub had all the same pointers and they just added to it, and I had all the same pointers and I added to it, then at the end of the day, I just realized that I hadn't switched to the other screen, so people were looking at your terminal instead of mine, so they knew what I was reading here. But if I had pointed different things up, if I had actually had different pointers than you have, it could be very confusing. But if I have the same pointers and you're just adding more that point backwards, then I can share my work very, very easily.
Right.
So whenever I do an interactive rebase, I'm changing history, clearly. When I do a cherry pick, I'm changing history, but generally, as long as it's on a later branch, it looks like a new commit no one cares about. If I'm doing an amend, I could be changing history if that's pushed as well. But if there's ever a question at all when I'm working with someone else, what I can always do, you saw in the very beginning we had new branch and we had the master branch. They both pointed to the same branch. I can make a brand new pointer. If there's any question if someone else is like, well, I want to rebase something, I'm like, oh, but I don't know if anyone else is looking at it. Let me make a brand new branch. So go ahead, let's do that real quick. I'll change to your screen so people can see it. And just make a new branch from UR. What branch are you on? New branch? Yeah. So do git checkout -b. That's a way we're making new branches and checking out. But use the new branch name of new _ branch _ R0 for revision 0. Now that's a new, enter. So that's a new branch. And if I push that branch, it's not going to affect any of the other pointers. It's a brand new set of pointers, a new path in. It can't affect anyone else. So as a working practice, if I think I'm rewriting history at all, I will just make a new branch so that I don't affect anyone else. Don't change the branch that you're on that someone else is already looking at, because that's just crazy. But if I create a new one that looks identical, 2 copies of the same thing like we saw, they work off of the new one, then they can see what I'm doing and it doesn't hurt anything at all. And I can always clean that up later when I'm going through a rebase.
So if in new branch R0 I do something like I amend or I do an interactive rebase, then it won't change anything about new branch.
That's right. Exactly.
Okay.
Because it's new pointers off of that branch. The old branch's pointers are not being affected by this one.
Okay, right.
Yeah. Copies and things. Yeah. So that's a good working practice to keep us from the more you have a different branch, the more people can work cleanly. You'll have extra objects in your database. Big deal. We can throw those away later.
Right.
So in general, how helpful was this?
Well, I use Git all the time for my projects, and it's mostly just been me working on them. So I usually have a stable branch that I share with people, and I work on my own branch. But lately, I've been working more and more with other people, and a couple times we've run into Git hell.
Fair enough.
I just don't really know what's going on, so what I tend to do is copy the code and delete everything and just start over or something like that. But I think I have a better understanding if my collaborators are working in another branch, then even if we go back and change history in another branch, then that's not a problem in the original branch.
That's right. In fact, I highly encourage keeping different branches, even if it's just _R0, _R1, _R99999. It's just new different things, and if you need to, you can just switch back to where you were to kind of see what things were before history got rewritten.
So I have one question. So if I do a merge, in my new branch I have stuff. So I have one sort of string of backwards pointers. And then if I I check out new branch R0, and I do, say, an interactive rebase, and then I want to merge that back into new branch. Then is that gonna a merge won't work quite right? Is that?
No, you should be fine. A merge will be quite right, but you want to make sure that you like when you're merging, it should be the final version of the branch. After it's merged, it's done and it's permanent in that particular branch, if that makes sense.
Okay.
Let me switch to a picture. Let me switch over to my original whiteboard, and I will show you a really quick artificial example that I'm throwing together. So these are different branches.
Okay.
There's code that's changed here, it points backwards, and there's code that changes. Oops, I'm not showing this again, sorry. Okay, so there's code that changes here on the left, and there's code that's changed here on the right. And my picture's not accurate if I'm pointing to my branch pointers. Let me just remove the branch pointers for now. It's not really relevant. So I have, or I will at least make it accurate looking, so it's something like this. So if that's a particular branch, and I have another branch over here called new branch 5, or some different type of working branch, I have two different branches that are working their way backwards to this original initial one. What a merge is a combination. So Git basically says from the history point of view, a merge will have two parents. You saw how you have parents in the file output?
Right.
A merge has two parents.
Okay.
So in this particular one, you can see I made up the numbers, obviously, but and I'm going to make one more hash at the bottom so it's obvious that it continues linearly backwards. Initial commit. So when I have a merge, there's code that's common to the left and the right, and this commit figures it all out, even if you have to go resolve some conflicts. So that whatever this commit does, it says it basically is a combination so that everything backwards from the arrow at this point in time is consistent. So I could follow the history back this way, I could follow the history back this way, but at the end of the day, when I get to this point, this top point, it's a merge of all the code. So at this point, anything that has it as a parent is fixed in time, if you will. Okay. Did that help?
Yeah, yeah.
So a merge is really a combination of two parents, and so that's how you can, once it's merged, all of those histories at this point are basically a set. And so what I do is I use something called git flow, or a variation of that, quite often in working practices, and that is where we will merge on what's called a feature branch, but it's just a branch that I'm working off of. And then we have release branches, and we have master, and we have develop. So frankly, it often happens to be that I work in develop. Let me see if I can erase this picture and start over. So often we have the long-running master branch. So the master branch is what really is going out there. And often these will have tags like release 1, release 2. Probably much more about production releases than you care about, but for what you're doing. But still, the idea is I have fixed moments in time where this master branch represents everything that we've done. Right. Long-running branch that is often the develop branch, which is where everyone's merging their code into. So you don't merge it directly into master. You merge it into develop. And then you can continue testing. Before you go to master, you have a point where you can, before you merge it into master, you have a point to make sure that all is good, test pass, things are very clean. But then you have all of these feature branches, many feature branches, which is much more what we looked at. And so we're all working on a different branch. And typically, I wouldn't even need to share my work because we all are working on our own little thing, a small feature branch. And then as it's happy everyone likes, it's merged into develop. So develop is something we all share that's fairly stable. But my changes are in the feature branch. Make sense?
Yeah.
So that's how you avoid a lot of this. Instead of having to work on the same branch like develop or master with other people, each person has their own little branch like fix bug 1, 2, 3, or go work on this bit of code. And then people can kind of look at it and even do a code review with GitHub and say, oh, I think that makes sense. Oh, that doesn't make sense. and then when it gets merged into develop, it becomes kind of canonical for everyone else, no one will change the history after it hits develop. That would be the big sin, if you will, because it would mess everyone up. And then, of course, going to master, and no one should change the history there. So the only history should ever be done is on a feature branch, and that's only until it actually gets merged into develop.
Okay. Yeah, this is what I guess this summarizes what it is I'm starting to try to do with my projects.
Excellent. And the nice thing about what we're doing now is that you are able to start seeing what's going on underneath. If you have to draw a picture, you could actually go look underneath and see what's happening, and you could actually construct a picture of what the branches look like if you ever get into a confusing situation. Follow the branches, look at their parents. It can be very tedious and detailed, but it can help you figure out what's going on if there's something that happened. But in general, working practices can avoid that simply by working in feature branches. Rebase all you want, but only you have, once you've shared that branch, that feature branch with someone else, never change it, make a new feature branch instead. Once you develop, never change it, ever, ever, ever. Once you go into master, ever, 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 don't ever change it, and people will be fine. They'll be working, and there'll be no problems at all. The problems will be much more less of a code. You'll have merge conflicts from time to time, but it won't be hell. Yeah, merge conflicts is going to happen a little bit. That just communicating a little bit more on the feature branches. But it's much less about, people are changing history while I'm working on it. That can be very confusing.
Okay.
All right. Well, thank you very much for your volunteering today. I hope it was helpful.
Yeah, no, thanks a lot. It was informative.
Cool. All right, we'll talk soon. Take care. Bye-bye.
Bye.